We don't yet have the know-how to properly maintain a corpse brain. That's why cryonics is a non-starter in our quest for immortality. Each cell in the deceased person's body is undergoing a dramatic biochemical change due to the lack of oxygen and nutrients, so that the state of a cryogenetically frozen body is not a state of a living human being. It's a scene plucked from science fiction. On their deathbed, a person is completely frozen and then stashed away so that they might be revived in the future. But could that be possible? In this excerpt from Why We Die, The New Science of Aging and the Quest for Immortality, HarperCollins 2024, Nobel Prize-winning biologist Venki Ramakrishnan examines the decades-long quest for cryonic preservation, in which people would be frozen at the point of death and defrosted in the future, and the pitfalls of an industry born out of the idea. Egyptians mummified their pharaohs so that they could arise corporeally at some point in the future for their journey in the afterworld. Surely now, a few millennia after the pharaohs, and with more than a century of modern biology behind us, we would not do anything even remotely so superstitious, but in fact there is a modern equivalent. Biologists have long wanted to be able to freeze specimens so that they can store and use them later. This is not so straightforward because all living things are composed mostly of water. When this water freezes into ice and expands, it has a nasty habit of bursting open cells and tissues. This is partly why if you fresh freeze strawberries and then thaw them, you wind up with goopy, unappetizing mush. An entire field of biology, cryopreservation, studies how to freeze samples so that they are still viable when thawed later. It has developed useful techniques such as how to store sperm cells and other important samples in liquid nitrogen. It has figured out how to safely freeze semen from sperm donors and human embryos for in vitro fertilization treatment down the road. Animal embryos are routinely frozen to preserve specific traits, and biologists' favorite worms can be frozen in larvae and revived. And for many types of cells and tissues, cryopreservation works. It's often done by using additives such as glycerol, which allow cooling to very low temperatures without letting the water turn into ice, effectively like adding antifreeze to the sample. In this case, the water forms a glass-like state rather than ice, and the process should be called vitrification rather than freezing. The word vitreous derives from the Latin root for glass, and even scientists casually refer to it as freezing and then specimens as frozen. Enter cryonics, in which entire people are frozen immediately after death with the idea of defrosting them later when a cure for whatever ailed them has been found. The idea has been around a long time, but it gained traction through the work of Robert Ettinger, a college physicist and math teacher from Michigan, who also wrote science fiction. Ettinger had a vision of future scientists reviving these frozen bodies and not only curing whatever had ailed them, but also making them young again. In 1976, he founded the Cryonics Institute near Detroit and persuaded more than 100 people to pay $28,000 each to have their bodies preserved in liquid nitrogen in large containers. One of the first people to be frozen was his own mother, Rhea, who died in 1977. His two wives are also stored there. It's not clear exactly how happy they were to be stored next to each other or their mother-in-law for years or decades to come. Continuing this tradition of family closeness, when Ettinger died in 2011 at age 92, he joined them. Today, there are several such cryonics facilities. Another popular one, Alcor Life Extension Foundation, headquartered in Scottsdale, Arizona, charges about $200,000 for whole body storage. How do these facilities work? Essentially, as soon as a person dies, the blood is drained and replaced with an antifreeze, and the body is then stored in liquid nitrogen, theoretically indefinitely. Then there are transhumanists who want to transcend our bodies entirely, but they don't want humanity as we know it to end before we have figured out a way to preserve our minds and consciousness indefinitely in some other form. In their view, intelligence and reason may be unique to human beings in the universe, or at least they see no evidence for extraterrestrial intelligence. To them, it's of cosmic importance to preserve our consciousness and minds and spread them throughout the universe. After all, what is the point of the universe if there is no intelligence to appreciate it? These transhumanists are content to have only their brains frozen. This takes up less space and costs less. Moreover, it could be faster to infuse the magic antifreeze directly into the brain after death, increasing the odds of successful preservation. The brain is the seat of memories, consciousness, and reasoning, and that is their sole concern. At some point in the future, when the technology is ripe, the information in the brain will simply be downloaded to a computer or some similar entity. That entity will possess the person's consciousness and memories and will resume life. It won't be limited to human concerns such as the needs for food, water, oxygen, and a narrow range of temperature. We will have transcended our bodies with the possibility of traveling anywhere in the universe. Not surprisingly, transhumanists are generally ardent about space travel, viewing it as our only chance to escape destruction on Earth. One such proponent is business mogul and investor Elon Musk, said to be the wealthiest person in the world, depending on the year, who is well known for his desire to die on Mars, just not on impact. Presumably, one of his first goals upon reaching the Red Planet will be to construct a cryonics facility. The bad news is that there is not a shred of credible evidence that human cryonics will ever work. The potential problems are myriad, but by the time a technician can infuse the body, minutes or even hours may have elapsed since the moment of death, even if the client moved right next to a facility in preparation. During that time, each cell in the deceased person's body is undergoing dramatic biochemical changes due to the lack of oxygen and nutrients, so that the state of the cryogenetically frozen body is not the state of a live human being. No matter, say cryo advocates, we simply must preserve the physical structure of the brain. As long as it's preserved enough that we can see the connections between all the billions of brain cells, we'll be able to reconstruct the person's entire brain. Mapping all the neurons in a brain is an emerging science called connectonomics. Although it's made tremendous advances, researchers are still ironing out the kinks on flies and other tiny organisms, and we don't yet have the know-how to properly maintain a corpse brain while we wait for connectonomics to catch up. Only recently, after many years, it has been possible to preserve a mouse brain, and that requires infusing it with an embalming fluid while the mouse heart is still beating, a process that kills the mouse, of course. Not one of these cryonics companies has produced any evidence that its procedures preserve the human brain in a way that would allow future scientists to obtain a complete map of its neural connections. Even if we could develop such a map, it would not be nearly enough to simulate the brain. The idea of each neuron as a mere transistor in a computer circuit is hopelessly naive. Much of this book has emphasized the complexity of cells. Each cell in the brain has a constantly changing program being executed inside it, one that involves thousands of genes and proteins, and its relationship with other cells is even shifting. Mapping the connection in the brain would be a major step forward in our understanding, but even that would be a static snapshot. It would not allow us to reconstruct the actual state of the frozen brain, let alone predict how it would think from that point on. It would be like trying to deduce all of the various aspects of a country and its people and predict its future development from a detailed roadmap. I spoke to Albert Cardona, a colleague of mine at the MRC Medical Research Council Laboratory of Molecular Biology, who is leading expert on the connections of the fly brain. Albert stressed that in addition to the practical difficulties, the brain's architecture and its very nature are shaped by its relationship to the rest of the body. Our brain evolved along with the rest of our body and is constantly receiving and acting upon sensory inputs from the body. It is also not stable. New connections are added every day and pruned at night when we sleep. There are both daily and seasonal rhythms involving growth and death of neurons, and its constant remodeling of the brain is poorly understood. Moreover, a brain without a body would be a very different thing altogether. The brain is not divided solely by electrical impulses that travel through connections between neurons. It responds also to chemicals both within the brain and emanating from the rest of the body. Its motivation is driven very much by hormones, which originate in the organs and include basic needs such as hunger, but also intrinsic desires. The pleasures our brains derive are mostly of the flesh, a good meal, climbing a mountain, exercise, sex. Moreover, if we wait until we age and die, we would be picking an old, decrepit brain, not the finely tuned machine of a 25-year-old. What would be the point of preserving that old brain? Transhumanists argue that these problems can be solved with knowledge that mankind will acquire in the future, but they're basing their beliefs on the assumption that the brain is purely a computer, just different and more complex than our silicon-based machines. Of course, the brain is a computational organ, but the biological state of its neurons are as important as the connection between them in order to reconstruct its state at any given time. In any case, there is no evidence that freezing either the body or the brain and restoring it to a living state is remotely close to viable. Even if I were one of the customers who was sold on cryonics, I would worry about the longevity of these facilities, and even the societies and countries in which they exist. America, after all, is only about 250 years old. This is by Venki Ramakrishnan on Live Science. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.